Good evening, everyone. Before I start today's tutorial, I'd like to give you the breakdown of my plan. I'm planning to cover all the 68 topics in the secondary school math syllabus in 6 major clusters. The first cluster that I'm working on was expressions and equations. That cluster I had planned to do it between 8th of June 2025, that's last weekend on Sunday, till 23rd of June 2025, that's next week part 1 on Monday. So far, I've done quadratic expressions and equations. Graphs will be done later. I've done equation of a straight line. That's the current topic that I'm going to present today. After that, equation of a circle. Number 4, formulae and variations. Number 5, simultaneous linear equations and matrices. Number 6, vectors 1 and 2. 7, differentiation. 8, area approximation. 9, integration. And 10, binomial expansion. That's volume 1. Volume 2 will involve arithmetics. That's all topics involving numbers. Volume 3, geometry. Volume 4, measurement. Volume 5, coordinates and all graphs. That means under that section of volume 5, all those topics that I will handle before then, which have graphs, I not handle graphs till I get to volume 5. Then volume 6, which is the last one, is commercial arithmetic. Feel welcome to today's tutorial. As usual, my name is Lovex Orengo. This is a tutorial dated 13th June 2025. This is my 6th tutorial. The topic of today is gradient and equation of a straight line. Part 1. For a line passing through 2 points x1, y1 and x2, y2, the gradient is given as change in y coordinates over change in x coordinates, which is given as change in y over change in x, that is y2 minus y1 over x2 minus x1. I've considered the second coordinate minus the first coordinate. The gradient can also be obtained if we subtract the first coordinate minus the second coordinate, that is y1 minus y2 over x1 minus x2. Consistency is key so that the answer is the same. To form an equation of a straight line, we consider a number of conditions and the pieces of information given. In this case, we have 3 conditions. The first one is given 2 points. We have the second and third one, which will come after this. Now, if you are given 2 points, number 1 or step 1, you obtain the gradient of using the 2 points. Part 2, you consider a general point xy and one of the points given and then equate to the gradient that you have obtained in step 1. Example 1 illustrates this one. Find the equation of a straight line passing through 2, 5 and 5, negative 8 in the form y equals to mx plus c, where m and c are constants. Constants means that those are pure numbers. Solution: the gradient is 5 minus negative 8 over 2 minus 5. I've taken the first point minus the second point. That gives us negative 13 over 3. Now I consider the point xy. I've considered 2, 5 and the gradient negative 13 over 3. Taking the change in y minus 5, the change in x minus 2 equals to negative 13 over 3. Cross multiplying gives me 3y minus 15 equals to negative 13x plus 26. 3y equals negative 13x plus 41. This 15 has crossed the equal sign to the right hand side. Then I divide all through by 3. I get y equals negative 13 over 3, x plus 41 over 3. This fraction should be expressed in the simplest form, that's mixed fraction. Y equals negative 4 and the third x plus 13 and 2/3. The same answer can be obtained in a different manner after obtaining the gradient. Now, that's method 2. If you have obtained the gradient, you can write the general equation y equals to mx plus c, then substitute that gradient for the m is the gradient, then substitute for x and y for that 2 and 5. I've taken up one of the points which were on the line. That is y equals to negative 13 over 3x plus c. When I put here 2, I put here 5. I open this bracket, I get negative 26 over 3. Crossing to the other side comes plus 26 over 3. I take the LCM, which is 3. This gives me 15 plus 26, which is 41 over 3. Therefore, it means C is 13 and 2 over 3. This one gives us the same answer that we had obtained in the first method, y equals to negative 13 over 3x plus 13 and 2 thirds. Condition number 2, to form an equation when given x and y intercepts. In this case, we are able to form an equation known as the double intercept equation, which is of the form x over a plus y over b equals to 1, where a and b are x and y intercepts respectively. For example, that's in example 2, a line meets x and y axes at 3, 0 and 0, negative 5 respectively. Find this equation. Solution. In that double intercept form, that is shown here, we write x over 3 plus y over negative 5 equals to 1. We take the LCM, which is 15, we multiply through by the LCM. This one gives us 5x, this one gives us negative 3y equals to 15. Taking this 3y to the other side, it becomes positive 3y. 15x on this side, it becomes 5x minus 15. That is 3y plus 5 equals to 5x minus 15. Dividing through by 3, I get y equals to 5 over 3x minus 5, which can be written as y equals to 1 and 2 over 3x minus 15. Third condition, given 1 point and the gradient. This one is part of condition 1, where we were given 2 points. Because after the 2 points, we are able to obtain the gradient, then we proceeded with one of the points and the gradient. Therefore, in this case, we consider a general point, x, y, the point given and the gradient, and then proceed as in part 1. Example, find the equation of a straight line whose gradient is negative 2 over 7 and passes through the point negative 3, 5. Solution, we consider point x, y, negative 3, 5, and the gradient which is negative 2 over 7. Change in y, y minus 5. Change in x, x minus negative 3 equals to negative 2 over 7. Closing equal cross multiplying gives us 7x minus 35 equals to negative 2x minus 6. This 35 cross equal sign becomes plus 35 minus 6, which gives us 29. Then we divide through by 7, we get 2 over 7x plus 29 over 7, which simplifies to y equals to negative 2 over 7x plus 4 and 1 over 7. Thank you for today. That's what I prepared for this session. In our next session, we are going to talk about other parts of the equation, that is parallel lines, perpendicular lines, and more other sections. Thank you. Welcome in advance in the next session.